Hi everyone. Today we're going to be learning about subduction zones. And this is still related to plate tectonics and specifically what's happening at some convergent plate boundaries. Should you need to get a hold of me, my email address is on the screen. It's rcrawford@jcpsmail.org. Let's jump right in. So the first thing I need you to keep in mind, and we're going to talk about this several times, is to understand what's happening at any tectonic plate boundary. And remember, a boundary is just where two plates come together. If you want some understanding, you first have to ask yourself two questions. The first question is, how are the plates moving? Are they divergent, meaning are they moving away from each other? Are they convergent, meaning are they moving toward each other? Or are they transform? Is it a transform boundary where the plates are just sliding past each other? Once you have decided that, the second question you need to ask yourself is what type of crust is on top? Is it going of the plates? So for a plate boundary, we of course have two plates. Is it two pieces of oceanic crust, which is thin and very heavy? Or is it a piece of oceanic crust and a piece of continental crust? Remember, continental crust is much thicker and it's much lighter, doesn't weigh as much. So we need to understand how are the plates moving and what type of crust is riding on top of each plate. Let's see how that plays out by looking at some plate boundaries here in a moment. First, I need you to, I need to introduce a new word, and the word is subduction. So subduction is very simply what's shown in this image. Whenever one plate dives underneath another plate, so you can see how we have plate number one here, and here we have another plate. Whenever we have one plate going underneath another one, that is subduction. And so really, whenever we have two plates, um, you may think, oh, well, which one's going to go underneath when they collide? Because remember, this is only going to happen at a convergent plate boundary, and always the oceanic plate is going to be the one that dives under. So a plate with oceanic crust on it will always dive under a continental plate. If we have a convergent boundary where we have two oceanic plates, then it's going to be the older of the oceanic plates that will dive under, and that's because it's slightly more dense. Um, let's keep looking. So subduction, that's just where one plate dives underneath another plate. Wow, there's a lot happening here on this diagram, but there's a lot of things you already know. So really, here we're looking at a plate boundary, and here's plate number one. I can see over here I have plate number one has some oceanic crust riding on top of it. This is a convergent boundary. I can tell by these arrows. Here, this is a piece of continental crust. I can tell by how much thicker it is. So I have a piece of oceanic crust that is being subducted underneath a piece of continental crust. So what happens here at this convergent boundary? Well, the first thing I want to point out is this area right here where that plate is diving, we call that a subduction zone. Okay? Now, I do want you to notice that we have right at that subduction zone where that plate is bending, we have an oceanic trench or a deep ocean trench. Remember, these are those long, narrow, extremely deep canyons underneath the sea. Guys, subduction is what creates ocean trenches. So any place you have an ocean trench, that's because it's a subduction zone. Okay? So as this plate subducts and it dives further down off into the earth, down off further into the mantle, the end of this diving plate is going to melt because we know that the further that we go under Earth's surface, the hotter it gets, the higher the temperature. So as the end of this plate melts, we're going to have magma that's going to rise up through this overriding plate, which is this continental plate. That magma is going to rise up, and eventually we're going to end up with a whole chain of volcanoes. We're going to end up with a bunch of volcanoes all up and down this plate boundary. Okay, so whenever we have a convergent boundary, oceanic and continental crust, We already know that we're going to have a subduction zone, okay, and we know the oceanic plate is going to be the plate that is subducted. We know that we're going to have a deep ocean trench. That's going to be our landform. We're going to end up with, on that continent, on that continental crust, we're going to end up with a long chain of volcanic mountains. Those are always going to form due to this plate melting. These are the landforms we're going to see. Guys, subduction zones are pretty violent places. Some of the biggest natural disasters that we have here on Earth happen at subduction zones. Of course, there's going to be volcanoes that were created by the melting of the end of this diving plate. Sometimes this subducting plate gets hung up, it gets stuck, and pressure can build up for years and years. So we can also have some very powerful earthquakes here at these convergent boundaries where we have subduction. Whenever we have an earthquake out underneath the ocean like this is precisely what an earthquake underneath the water, that's precisely what causes a tsunami. So, you know, these are pretty violent places. So if we look at some examples of this, we're going to find that all up and down the coastline here, these are all subduction zones, right? So these are the Andes Mountains up the coast of South America. This is the tallest chain of volcanic mountains on our planet. And by the way, you see this little plate boundary here? This also is kind of showing us where that oceanic trench is. Notice that all along the outside edge where we found all those volcanoes, all along the outside edge of the Pacific plate, those are also subduction zones. So as a result, we're going to have all kinds of volcanoes here. I do at least want to go back and look at something that is so similar that I don't want to spend a lot of time on it. So the only difference in this drawing is the type of crust that's overriding. So here we have plate 1 has oceanic crust on it again, but notice that plate 2 also has oceanic crust. The only difference between these two is going to be that we're still going to have volcanoes formed. We're still going to have subduction. We're going to still have a trench. The only difference is those volcanoes are going to be submarine volcanoes. And so that means those are just going to be active volcanoes underneath the ocean. Sometimes those active volcanoes are going to erupt enough to form a chain of volcanic islands, right? So instead of the volcanoes being on continental crust, the volcanoes are going to be under the sea. And so a convergent boundary where that's oceanic and oceanic crust, where one plate is diving, we're often, instead of volcanic mountain chains on a continent, we're often going to end up with volcanic islands or submarine volcanoes out on that plate. And so I think that's going to do it for today, guys. Subduction is really is one of our big processes in plate tectonics, this idea of one plate diving under another. I hope you guys have a great day.